This is what you've built as a result of experiment 2, which is entitled Memory. Quite a few components have been populated. You can see the input data switches, which are going to be used for both data and address. They're AD0 through AD7. The 8 LEDs that are the lower 8 bits of the data bus and address bus. A bunch of resistors and 2 chips that are going to be used to drive the LEDs. Up here in the upper left, you've also installed the components for the regulator, which is a 5-volt regulator chip, and the power switch. First thing we want to do is see if we do in fact have 5 volts. Now you'll notice that I haven't installed the heatsink for the regulator. It's not on there. It's really, at this point, it's in the way, and the circuit's not drawing enough power to make that regulator get hot, so I'd recommend just leave it off. So I'm going to clip my DMM ground up to the tab of the regulator. That's a nice convenient place to clip that on there. Just be careful you don't short across something. And below there, you'll see a point marked plus 5 volts, and that is the 5-volt output of the regulator. If this isn't working right, you need to stop and find out what's up there. So I'm going to flip the power switch on. We have a nice LED lighting up there, and you can see we have 5.02 volts. The limits for 5 volts are 4.75 to 5.25, the same as the normal limits for a regular TTL circuit. So it looks like we got good power. Let's see if the data input switches are doing their job. So we'll just kind of pan down there. All you should see is when you flip a switch up, the corresponding LED for that switch should turn on. That's telling us that the switch is getting data on to the data and lower address bus, and the LED driver circuit is working so that we can see the result. This will be important as we go into the next experiment where we're actually going to read and write some data from the double EEPROM.